Hello, the project which we are going to discuss is IoT based liquid management system using system on chip. We'll be discussing about why this liquid management system is essential and how Texas Instruments low cost solutions will be provide a feasible solution for this. They are my teammates. Uh, my name is Lalit and he is Vasan and he is Jeru.
Module EZ430 RF2500 module and Tembo based IoT solution. So why liquid management system? The task of monitoring and controlling a system, especially a liquid flow system, is a complex task considering the amount of parameters to be monitored such as temperature, flow, pressure, etc. This project aims at creating an Internet of Things based solution to solve the problem using a Tembo based interface instead of a traditional SCADA. So data obtained is logged over directly to the internet through a secure gateway. Block diagram implementation of our liquid management system. It consists of two sensors, one control element which is the solenoid, and one indication unit which is the liquid level indicator. A BTU is the amount of heat required to increase the temperature of a pint of water which weighs exactly 16 ounces by 1 degree Fahrenheit. BTUs are measurements of energy consumption, British thermal unit. Now what is the significance of BTU? BTU is an essential part of a building management system in a green building. A green building's ratings are actually determined by the BTU measurements. HVAC systems efficiency can be graded using the BTU it generates. Waste heat recovery units can also be built around the liquid management system using BTU measurement. BTU measurement principle is simple. The difference in temperature between the supply line and the return line and the product of the difference with the flow rate into a liquid constant gives the number of BTU generated by the system. So our liquid management system will attempt to exploit this feature in order to obtain an accurate BTU measurement. So this is the BTU relation with temperature and flow. For water, its flow rate into the temperature leaving the LMS minus the temperature entering the LMS into the liquid constant.
Details of the various sensors used in this project. The first one is the temperature sensor and the next one is the flow sensor. The PT100. It measures temperature in comparison to change in resistance. These sensors are placed inside pipes in order to measure the temperature of the fluids, and due to its protective outer covering, it is rapidly replacing its counterpart, the thermocouple, in measuring temperature of liquids of high temperature. The design that we've used is the TF101U2, and for our project this temperature has been ambient enough to work within a temperature range of minus 30 degrees centigrade to 105 degrees centigrade. The advantages that it offers are its repeat time, and it also offers a high accuracy, which is the main purpose 201. It works on the principle of Hall effect. the working voltage that we've observed using the MSP 430 is 3.5 volts to 18 volts DC, and the rate of flow is 1 to 30 liters per minute, and for every liter that passes through the flow sensor, it generates a pulse rate of 450. The frequency can be calibrated using the formula 7.5 constant multiplied by the flow rate, which is calibrated in liters per minute. The flow sensor. The first two wires are the normal standard convention, that's the ground and the voltage VCC. And the third pin receives digital input for each pulse generated as the water flows into it, and depending on the rate of the flow, the pulses generated are either fast or slow. Thank you.
Hello. We'll discuss about how the project is implemented in real time using hardware. We'll discuss about each and every component whichever we use for just real time application. Let's get started. This is the major board what we are using. The major part which lies here is these two and this one also. It looks a small thing. As such, like we have in our project, we have not used anything very big stuff like very big LCD displays and all. It's very simple. Only few devices which are available in TI. We purchased it and then we did the project. The main motive of our project is reducing the cost, reducing the size, basically reducing the loss, reducing the cost and reducing the complexity. So just by using smaller components, we are able to get this small devices are capable enough to control a real-time non-linear process. That's what we are going to implement it today. Let's see in each and individual components. This is the CC3200 Wi-Fi module, and this is the MSB430 device. Well, I'll tell you why we are going for this MSB430 device. And these are the two EZ430 communication devices. This is the AP device, that's the access point device, and this is the end device. Like end device is which is connected to all the sensors. Main thing why we went for this MSB430 is that using this EZ430 we can easily build a WSN network, that is a wireless sensor network. Just for this wireless sensor network we use for the MSB430. Like we have connected one TIIC of this access point to MSB430, like to an UART. Likewise, several number of EZ430s can be connected here and can be monitored. That is the main reason why we went for the MSB430 part here. And these are the small peripherals, like 12 volt supply, 5 volt for connecting to relay, and this is the 12 volt relay board. And this is the solenoid valve, and this is the flow sensor, and this is the PT100. So using these devices will show how it is. From this solenoid valve is switched on now, and flow sensor and PT100 will measure the flow and the temperature respectively. Here what we have done is that we have hard-coded the value. The flow sensor should allow only 20 liters. That's a huge liter, but as such for demonstration we have done it like flow sensor should allow 20 liters. So what happens is that 20 liters it will count for each and every input. It will give a output pulse. So based on the pulses we'll be calculating the flow. So as it reaches the 20 liters, it will switch off the solenoid valve. And these data, the flow sensor data, solenoid valve is controlled using relay, PT100, and there is a level sensor also here. So this level sensor also is loaded into XCPU. If you see this system here, we have seen the sensor 1, sensor 2, sensor 3 values. Now if you see the hard-coded value whichever we give it has reached. So what happens is that the solenoid valve switches off and flow sensor and PT100 values are just displayed in the XCTU. If you see the outlet is just only few droplets are there, that is because of the flow sensor. It will not immediately switch off, so it will take some time for the remaining liquid to flow out. So flow sensor, PT100 values will send out this data. If you see the sensor values, as such, what happens is that sensor values as such, if their values are coming, then it will be varying. Now since no value is there, it is just showing the 5 volt, that is 1023. How I have coded is that, it is like it is ADC value. We have transformed these values whichever are shown are this ADC values. The 1023 belongs to 3.3 volts. So how we have done is that as the voltage comes in, this value reduces. So that's why the previous XCTU terminal we saw some 500, 600 and all. And these values, how we are going to do it in IoT. That is the main topic of the environment. Texas Instruments provides a versatile development platform called Tembo. So using Tembo, you can directly monitor the device, monitor the data, or you can control it, or you can do several things using Tembo. And this is an energy code for that. So using CC3200, we have created a Google username and a password and the spreadsheet title also. Here in this title, we have given the raw data as device and value. How much is the device and how much is the value we are getting in the real time scenario. And remaining all are just inbuilt functions. The Tembo values, whichever I was telling about the logging part, like in the energy code, these logs I have already made a document and downloaded it from the Google Docs. So if you see the same thing, whichever we got in the XCTU, sensor 1, sensor 2, sensor 3, the same way it is getting all this data. I told you about the 657, 789. As such, if the node data is coming, it is 1023. As the input comes in, this value reduces. So based on these values, we can calibrate it. These values can be taken using any software and be used for creating a GUI also. So it is a multi-purpose data logging.